So the lesson for today is, there we go, simplifying algebraic expressions. All right, by combining like terms. I say CLT. I hate to write. All right, so the first thing that we got to learn is the definition of a term. A term is defined as, it could be a number, it could be a variable or variables, or the product of the two, separated by addition. All right. Example. Twin J. Give me an example of a number. In a number. Two. All right. Alex, give me an example of a number. Seven. TT, give me an example of a number. 10. AJ, give me an example of a number. -8. Very good. Cam, give me an example. Okay, so I'll start with Cam next. So these are all numbers. Cam, give me an example of a number. Great job. 3/7. That's what I heard you say. Now, and Rob, give me an example of a number. Ooh, -40. I'm with it. Now, give me an example of J Scribb. Give me an example of a variable.
8.
All right, 8. All right. Alice, give me an example of a variable. Y'all better not do this to me. TT, give me an example of a variable. Thank you. Oh, listen, ABC. Rob, give me an example of a variable.
N.
All right. N squared. All right. AJ, give me an example of a variable.
X, Y, Q.
All right. X, Y, Q. There we go.
I got one.
All right. TT, give me. Oh no, I got TT already. Cam, give me an example of a variable. All right. I like that one. E. All right. Now, so what we have numbers. That's a number can be a term. Variables can be a term. Whether you got one variable by itself or several variables together. These are all terms. Or the product of the two. Here we go. TT, if I multiply 2 and A, what do I get? Good. Rob, if I multiply 7B, what do I get?
7B.
All right. So anytime you multiply numbers and letters or just letters, they just go side by side. Alex, if I multiply 10 and M, what's my term? 10M. All right. J Scribb, if I multiply -8 and N squared, what's my term? -8 N squared. All right. Rob, if I multiply 3/7 and XY cubed, what's my term?
3/7 XY cubed.
Smart. And Scribb, Cam, if I multiply -40 and E, what's my term? -40E. Now, a term can be a number by itself, it can be variables by itself, or it can be a product of those two things put together. Now, let's see. Let's go here. Now, like terms. Like terms. Like terms are defined as terms. Now you know what a term is. terms with the same variable all right, same variable or variables with exactly the same exponents. All right, with exactly the same exponents. For an example, two p comma mean and, all right, 2p and 4p squared. Are these like or unlike? Why? How you know? They have the same variable, but what's wrong? Now, everything has an exponent. What number? The only number we don't write all the time is the understood one. So if we don't write ones in math unless there's just a number by itself. But for the most part, for the exponent, if you see a number, if you see something, it has an exponent on it. That's 2 to the first power, p to the first power. 4 to the first power, p to the second power. If you don't see an exponent, there is one. All right. So these are unlike. All right. Let's do it again. What about? Use my cheat sheet. All right, what about (3m squared) and negative 6m squared? Are these like or unlike? How you know? Variables, so m and m, and now look at the exponent, 2 and 2. So these are like. Doesn't matter what the coefficient is. No, you only look at the variable and the variable's exponents. All right, let's keep going. Oh, sure can. Did we get in there? Did we get in there? There we go. All right. 3x and 2/3. Are these like or unlike? They're unlike. How do you know? They got nothing to do with the fraction. I know you don't like them, but they got nothing to do with the fraction. Like terms mean they got to have the same what? Variable. What's wrong with 2 over 3? Ain't nothing wrong with it, but why it can't be like? There's no variable. There's no x with that. There's no variable. Don't have the same variable. All right, there you go. All right, here we go. What about 7? Like or unlike? Why, Gates? How you know?
They got the same variable.
Same variable.
Yeah.
Same variable. It did not say, and they got to be in order. Didn't say that. Where you paper at, man? You got no paper?
So as long as they not.
Come on, jump on in. Let's jump in.
I don't know. I don't like starting like that.
You got to though. You got to jump in when you jump in. You jump on in there.
Alright.
Yeah. Oh yeah. All right. Last one. Last one. 4 and 2/5. Is this like or unlike? It is like. Just because you don't like fractions don't mean nothing. These are like terms because they both don't have variables. So all constants are like terms. Now, the next note or the last one that I have before we start practicing is we have to now get into the first part of simplifying is combining like terms. Combining like terms. All right. To combine like terms simply means to add or subtract the coefficients. That's it. You add or subtract the coefficients. I just say of like terms. We'll say that of like terms. All right, let's see if we can pause for a minute here. All right. So, if I had to give you some rules for this, Some people like rules. All right. I would line up the like terms. Rule 2. Add or subtract the coefficients. And rule 3, place a plus between unlike terms. All right, that's what I would do. And for a caveat, I would say place terms in alphabetical order, not by number, by letter. All right, I won't take off if you don't put them in alphabetical order. That's where we're gonna start.
All right, let me guide you through about 4 problems. Let's go. All right, the first problem is 2x squared plus x minus 3x minus 4. All right, so rule 1 is line up your like terms. So let's take the first one. The first one is 2x squared. All right, you have any other x squared in your problem? No. So we write a big plus sign. All right, next term, we put the x. All right, do we have another regular x in your problem? Yes. So remember, you keep the sign. So that's negative 3x. Then big plus sign. You go to your last term, negative 4. There are no like terms for the negative 4, so just put it down. Draw your arithmetic line. 2x squared. There's nothing to combine it with, so it comes down. And plus sign. Now, if you only have an x, remember, a x is like $1. That's 1. All right, so 1 and negative 3 have different signs. Different signs you subtract, you get 2. 3 is farther away from 0 than 1, so your answer is a negative 2. And bring down your x. So when you combine it like terms, the variables stay the same, but the coefficient changes. Plus, and we have negative 4. And that's it. All right, let's go to number 2. All right, so we have 5ab minus 3bc plus ab plus 6bc. All right, the rule says line up your like terms. Let's do it. Start with the first one. So we have 5ab. Do you have any other ab's in the problem? Right there. All right, so we're going to say AB. All right, and no more AB to the problem. So we say plus, we move on to the next one, which is a negative 3BC. Negative 3BC. Do we have any other BCs to the problem? Yes. So we have 6BC. All right, so we lined up our problems. Now it says add or subtract the coefficients. All right, let's do it. So these are, so if you don't see a number in front of the variables, put a 1 in front. So 5 and 1 is 6, and AB just comes down, plus, all right? These are opposite signs or different signs, positive and negative. When you have different signs, you subtract. 6 minus 3 is 3. It's going to stay positive because 6 is farther away from 0 than negative 3. And the variable is still BC. All right, just a couple more. Third one would be. All right, 7p squared minus 4pq minus 2q squared plus 6p squared, pq. All right, so the first thing is line up like terms. So I see I have 7p squared first. Do we have another p squared? No. I'll put a plus sign. I'll go to the next one. Next term is negative 4pq. Do we have another pq? Yep, right there. 6pq. All right. All right. Plus, the next term is negative 2q. Negative 2q squared. And that's all the terms. Draw a arithmetic line and combine like terms. When you combine like terms, only the coefficient changes. So 7pq is the only one we have for that one. 4pq and 6pq, well, that's -4. You have different signs, so you subtract. 6 and 4 we subtract is, well, plus is 2. It's positive because 6 is farther away from 0 than 4. And pq comes down, plus 6 and -2 are, I'm sorry, I'm here. -2 don't have one. That was the original problem. We don't have any like terms with q squared. We just say -2q squared. That's it. And then number 4. So the first term was x squared, and then the next term was -x squared. See, right up under each other. All right, we have no more x squared, so plus my second term is -2xy. Do we have any other xy's? Right there. So 6xy. Have any other xy's? Nope. So put a plus sign, and my last term is -y squared. Do we have any other y squared? Right there. -2y squared. Put your arithmetic line. Let's do it. Now remember, you don't see a coefficient, put a 1. So different signs subtract. What's 1 take away 1? 0. You have 0x squared. So why write anything? You don't have any x squared. So let's move on. The signs are different, so you subtract, and we get 4 is positive because 6 is farther away from 0 than 2. Bring the xy with it. All right, always bring out your plus sign. Remember, that's a -y squared. If you don't see a 1, understood 1. All right, same sign add, different sign subtract. We got the same signs, 1 and 2. That is a 3. It's going to say negative because they are both going in the same direction. Y squared. All right, now the last little rule says make sure that in alphabetical order. Let's look at number 1, the terms on alphabetical order. Let's look at number 1. Number 1 only have x's. Okay, so in that case, you go with your highest x. Whoever has the highest exponent goes first. There's x to the second, there's x to the first. Okay, that's good. Constants are always written at the end. So 2x squared plus -2x plus -4. Good. Next one, number 2. Remember, alphabetical order. This one starts off with an A. This one starts off with a B. It's in order. 6AB plus 3BC. Number 3, alphabetical order. Elemental P, Q. So P, both of these have P's in them, but you go to your highest exponent, P squared. All right, then 2PQ, and then just the Q. All right, it's good. And here we have X, Y, and Y. If you say it's ABCs, X coming before Y, so that's why this one works. All right, so they're all in alphabetical order. So for practice, I want you to practice 10 through 17. I want you to practice 10 through 17. Those are the ones what you do for this lesson here. Now there's an answer bank down here at the bottom. Your answer should be here. Now if it's out of order, that means that you didn't put it in the right order. It still be considered correct even if it's out of order, but it is customary to put them in alphabetical order. You want to put your answer in alphabetical order when you finish.